Hello, everyone. Thank you all for joining us here today. My name is Will Jettinghoff, and I'm joined by my partners, Cindy Jin and Yadong Liu. And we're going to be presenting to you the work we've been doing for the past few months on trying to increase transparency in Canadian democracy by mixing data journalism and data science. As GA mentioned, our work is a collaboration between the Data Science Institute here at UBC and the Investigative Journalism Foundation, who we were fortunate enough to work for this summer as interns. And the Investigative Journalism Foundation is a nonprofit newsroom here in Canada. It was just launched earlier this year in January. And their mission is to strengthen Canadian democracy through publishing investigative, data-driven stories, and also by maintaining public interest data sets on political activity, which they mine for the content of their stories. So the Investigative Journalism Foundation maintains a variety of data sets. So I'll go through them very quickly. One of the data sets that they have maintained and that we'll be working with today is a data set on political donations in Canada. So that records who has donated to which politicians in Canada for several decades now. They also maintain several data sets on charitable behavior in Canada, including the tax returns of different charities, the compensation that charities give to their staff members, and also the gifts that charities give and receive to each other. So charities can actually give monies to each other. And then finally, the IJF maintains a very extensive database of lobbying activity in Canada. That includes a registry of all special interest groups who are registered to lobby. It includes the government funding, which these different organizations have received over the years from different government offices. We also have the actual day-by-day communications that lobbyists engage with public servants. I'll go into more detail on that later. And then finally, the IJF maintains a revolving door registry. And revolving door lobbyists are a special type of lobbyist who used to be a public servant themselves. So maybe they've been lobbied and they know what it's like. So they have a particularly high impact for lobbying, or high impact potential for lobbying. So that's why that data set is particularly valuable. Now, this summer, we were only able to really scratch the surface of what the IJF has. We were able to work with the donations data and the lobbying data. So that's what we'll be presenting on today. And the charities data, that's not to say that the charities data the IJF has isn't very rich and interesting. I think there's a lot of good work to do there, maybe for future DSSG fellows. Okay, so let's get into it. So all of these data sets that I've just shown you share one thing in common, which is that they're all presented to users in what we in data science would call a tabular format. So in this format, each row represents an observation. So because we're looking at the political donations data set, each row here is a different political donation. And the different columns in this tabular format represent different features or attributes or characteristics of that donation, like the region that the donor lives in, or the amount of money that they gave. This tabular presentation of the data is incredibly intuitive and tidy. I'm sure everyone has seen something like it working in Excel before. It's also very easily searchable and filterable. So it's a great tool for holding special interests accountable in Canada and keeping things like lobbying and political donations transparent. But most importantly for us, this tabular format opens up many opportunities for data science. And we're gonna talk through those opportunities and the different deliverables that we made in turn. So with that, I'll hand it off to my partner, Cindy, who is going to talk about the first group of work we did.
So as Will said, all of our work this summer was based on the IJF's tabular database. And we've been mainly focused on three of them, which are donation database, lobbying communications database, and revolving door lobbying database. So actually, this tabular database can give us a lot of answer to a lot of fundamental questions about Canadian politics, but they're actually hidden in tons of columns and rows in tabular data. So what we did was to build a dashboard of bar plots to make these answers more obvious and straightforward. Next, I'll show you a demo for the dashboard we built for donations data. So here, You can see we built some filtering functions. You can search by donor type, which could be individuals or corporations, etc. And also you can put in donor name, donor FSA, which are the first 3 digits of the Canadian postal code, and also donor province, recipient name, political party. For example, could be Green Party of Canada, Conservative Party of Canada, and also political entity, which could be party or candidate or registered associations. Finally, you just need to select a time range. Here, I'm just selecting all the data from this year, and you just need to click search and wait for a few seconds. The first one here is top political parties, and you can see the political party names are shown on the x-axis, and on the y-axis is the number of donations going to that political party. And the number on each top of the bar are actually the exact number of donations. And also you can hover each bar to see the detailed information, which are actually the same, like political party and number of donations. And for top donors, similarly, we can see the donor names on the x-axis, but this time on the y-axis, it is the total amount donated by each donor instead of the number of donations they have. So again, here's the total amount of donation. The third one is the province with highest amount per donation. So this one is the most different from all the other bar plots we have, because before we visualize this bar chart, we actually did some calculation to calculate the average amount per donation from each province. And the reason we did that is because different province or territories can have very different number of populations. For example, Ontario has the largest number of population, so it will always have the largest number of donation and also the largest donation amount in total. So here we just want to make the comparison more reasonable. And now we can see Ontario is no longer top 1 in the bar chart. It is Alberta. This one is top political entities. Actually, we cannot gain that much information compared to other bar charts. We can only see, okay, in 2023, party is the most dominant category among all those political entities. But in the last bar chart, you can see some detailed information. Like for the top 6 or 7 categories, the recipients are all parties. And for the rest of the 4, the recipient are actual person names. So here you can see the axis label are pretty long because we're not only putting the recipient name on as a label, we also append the political party they belongs to. So like for Richard Peterson, you have no idea who this person is unless you get an idea who this person, which political party this person belongs to. So that is pretty much about our donation dashboard. And one second. Just want to mention that we also built a similar dashboard for the lobbying communication data and revolving door lobbying data, but they're basically like in the same structure. So I won't go through the other 2 dashboards, but if you're interested in, then we can maybe go through some details during the Q&A part. But here, next, I will just pass it to you, Will, again, to introduce what we did to the lobbying communication data.
Thanks, Cindy. Yeah, so Cindy mentioned users are going to be able to use these dashboards once they live on the IGAF's website to look up information on donors, lobbying, whatever, for whatever region, time period, subject matter, and so forth they're interested in. Now, as Cindy mentioned, one of the main ways that Canadians can influence their politicians is by giving them money. But another major way that politicians are persuaded and that everyday people can interact with politicians is through lobbying. Or not everyday people, really, rather special interest groups. Although wealthy individuals can hire lobbyists, special interest groups will hire lobbyists to communicate with a public servant on their behalf about some matter of policy, be it about bills and regulations, the awarding of grants and funds to different special interest groups, or even the awarding of, say, labor contracts for something like building a new highway or something like that. Now, as you can imagine, special interest groups across the country, such as trade associations, private companies, law firms, public relations firms, and so forth, all have lots of their own unique agendas. And so lobbying really creates this large underground network in democracies around the world, not just Canada, where there are a variety of special interests vying for attention and trying to persuade our leaders to do specific things in their favor. Luckily, as of 2008, Canada has collected data on lobbying activity. So specifically, lobbyists have to disclose any time that they have a communication with a public office holder in an electronic registry that the government maintains. And so this is a major step towards helping Canadians hold these special interest groups accountable, because we can scroll through these communication reports and just immediately see who is talking to who and what they're talking about. So we see here, for example, that TELUS Spark Science Center in blue is meeting with two designated public office holders, Marta Gomez and Shalog Hayes, and they're speaking about economic development, regional development, and tourism. We also get a date stamp for that communication. So this is great. We can use this information to try and hold lobbyists accountable for what they do. But the thing is that lobbying is quite complicated. There are a variety of different kinds of special interest groups that hire lobbyers. There are a variety of different kinds of lobbyers that come from different backgrounds. The type of employment can be different. Sometimes there's payment via contract or salary. Sometimes it's just some sort of cooperative relationship and no payment is exchanged. And there are also a number of policymakers who have different sorts of positions and incentives. So it's a very complicated system. But what prior academic work has shown in policy and political science is that the real secret sauce in this whole community is the relationships that lobbyers have with policymakers. So if you're a special interest group like TELUS or some sort of trade association, when you pay for a lobbyist or you hire a lobbyist, what you're really paying for are their relationships and the access that they have to public servants who have some sort of power over something you're interested in. So as a result of connections being the most important part of lobbying, we can really think of lobbying as a social network of connected entities. We have various kinds of special interest groups who are connected to lobbyiers, and lobbyers connected to different special interest groups because they've been targeted by them for certain reasons. So one of our primary goals this summer was to take this tabular data set that I showed you earlier and convert it into a network visualization that users can actually explore to visually see what's happening in lobbying in Canada. So I'm going to switch over real quick to a demo of what this visualization looks like. And I'll say while I'm switching over that for right now, this visualization lives on our computers. However, we're hoping that soon it lives on the IJF website so that everyday Canadians can access this tool just like we are now. Okay, so what I'm showing you now is a network of lobbying communications on Aboriginal affairs. This is one of the subject matters that lobbyists can pick to label their reports for the last 2 months. So we can see that in the last 2 months of lobbying on Aboriginal affairs in Canada, there have been around 330 unique political entities active in this network. So those are either entities that are trying to reach out to politicians to talk about this topic, or they're politicians who are being reached out to talk about this topic. And we also see that among these 330 entities, there are 375 unique relationships in the data. Sorry for not spotlighting that better in the top left. Drilling down a little bit deeper by looking at the graph itself, we can immediately see who is doing the most lobbying. So right here, we see that the Breakfast Club of Canada, this is a nonprofit organization run out of Toronto, I believe, is doing the most lobbying on this topic. We can tell both by the number of lines coming from the Breakfast Club of Canada, and we can also tell by the fact that the Breakfast Club of Canada's circle is a little bit bigger than all of the others in the network. I should also mention that the triangles in this network are the actual public servants that are being reached out to. So by selecting specific public servants, we can see, for example, what their position is. So this is Dan Vandal, who's a member of the parliament here in Canada. And we can see that in the last few weeks or months, he's been lobbied by 3 different groups: the International Boreal Conservation Campaign, the Breakfast Club of Canada, and also what I would guess is a First Nations group. So using this visualization, Canadians can see where the most lobbying is happening, who is conducting the volume of lobbying in a particular subject matter, who they're speaking with, and so on. Just a moment. Okay. Right. So we hope that this lobbying network makes it easier for Canadians to literally see what's happening in lobbying in their country. But the network is admittedly complicated. And what we just showed you was only 330 of the active entities in the network. But there are actually over 19,000 different entities in the network and over 105,000 unique relationships. So this presents a real challenge for anyone who wants to look at the lobbying network because they have to choose a very small subset of the network to actually look at if they want it to be a functional, pleasurable experience. So what we wanted to do was assist users who aren't experts in data or journalism or even Canadian politics by giving them recommendations for entities that they might be interested in based on other searches that they make on the IJF website. So for example, a user might come to the website interested in the lobbying activity at TELUS, and so they would search for TELUS. And the idea is that our recommendation system would suggest other political entities to them who engage in similar lobbying activities in the lobbying network. So this is a problem that we're definitely not the first to encounter. Private organizations trying to sell you things have been trying to work on a very similar problem for many decades now. They often make recommendations based on geographic tailoring, time tailoring. So for example, you're probably not going to get recommended a snow shovel in the middle of the summer. However, more modern recommendation systems often work on similarity scores. So for example, when you're listening to a song on Spotify and it suggests you a new song, it's usually doing that because the model thinks that the new song is somehow similar to the one that you're currently listening to, either because people often buy that album together, maybe they often listen to that song in the same session that they listen to the other song, or maybe the lyrics just sound similar if we were to actually look at the text. But in our case, we're not trying to suggest products, we're trying to suggest political entities. Right here, I have some telecommunications companies, but you could also think of politicians, for example, like Jagmeet Singh. So then the question this poses us with is, how do we actually measure similarity between these different political entities? So this example is pretty easy for a human. We all know that Rogers and TELUS are telecommunications companies here in Canada, so they're quite similar. But a computer doesn't know this. And so we need to train it to do so. So the way that we do this is we plug in our giant lobbying network of over 19,000 nodes from about 15 years of activity into a graph neural network called Node2Vec. And I'll explain briefly what Node2Vec does, but basically what Node2Vec gives us is similarity scores between all these different entities. And Node2Vec does this in 3 steps. So I want you to imagine that what's on the left here is our lobbying network, and that each one of those nodes is maybe a different politician or a company. So what Node2Vec does is it takes thousands and thousands of random walks throughout this network. And as it takes these walks, it learns where important features of the network are, like different hubs. For example, you can see nodes C, D, E, and B seem to form a community. It might also look at dead ends, like nodes G, A, and K, and start to learn where those dead ends are. So it takes these thousands and thousands of walks, and it accumulates all of these different graph features to learn where nodes are. And then after these thousands of walks, it gives each node an address in this network such that similar nodes are given similar addresses. So then later on, when a user, for example, searches for TELUS, but they're interested in what other companies like TELUS are doing in the lobbying community, they'll get recommendations for lobbying entities that actually are lobbying in similar ways to TELUS. So we right now just have a working prototype of the recommendation system. So I'm showing you the top 5 recommendations for TELUS here, just to get you a sense of the quality of the recommendations and whether they make sense. And I do want to say here that our algorithm has no idea how the entities are spelled. So it's just a coincidence, or perhaps not, that our algorithm is correctly suggesting many other communications companies when a user searches for TELUS, which is good news for us. Yeah, and so my hope, or our hope, is that this tool will help users more effectively navigate the network that we just showed you without having to have expert political knowledge to do so.
So Will just showed us like very cool networks that shows the connection between the lobbying companies and the public servants. We can also see the public servants' affiliation. We can also see the frequency of their connections or not seeing from the communication report. from the network is what actually they talked about. That kind of information isn't available in the report, but that kind of information is available in the registration record, which they need to log in what they plan to talk about in the next period of time. Here is one example of one registration record done by the Canadian Pacific Railway Company. In their text, you can tell that they are talking about policies and regulations. For policy, they are talking about a consolidation of railway crossing policies, railway safety. Under the regulation, you can see infrastructure project, use of data collected, things like that. This kind of registration happened in this year, on April 14th of this year. This kind of plan or this kind of goal can change over time. For example, the same company, Canadian Pacific Railway Company, in August, this month, last week, they also did another registration. Aside from the thing they talked back in April, they had something new. For example, bill. They had legislative change to the Canada Labor Code, and they also add one more thing in policy, which is the labor stability thing in policy. So what they plan, their goal can change over time. So for the same company. Another interesting fact about this registration record is that different companies can actually talk about very similar things. For example, Rogers Communications, in one of the registration records, they're talking about broadband, broadcasting, and telecommunications. As Will suggested just now, this company, Rogers Communication, is in the list of top similarities of the company called TELUS. Here we go, TELUS Corporation. In one of their lobbying registration record, they are also talking about broadband, broadcasting, and telecommunications. The text aren't exactly the same, but the topic are in general very similar. How do we keep track of this? We just mentioned like there could be change over time. There could be also different companies talking about very similar things. How do we keep track of the topic change over time? How do we group different companies that are talking about the same thing, same topic? What we use is BERT topic. It is use the advantage of a large language model, trying to extract topics from lobbying registration record. We extract the unigrams, bigrams, and also trigrams as representation for the topic. We are visualizing those change over time in a word stream. I'm gonna show you a word stream demo just in 1 second. I might have to scroll back and forth to be able to show you everything. What you're seeing right now is all the topics happened between the year of 2008 up to now. Different color means different part of speech. So we have blue, we have nouns in blue, we have verbs in orange, we have adjectives in green. Let's look at something recent, something like we're all familiar with. So first of all, COVID-19 test happened or being talked or being lobbied about mostly in 2020 to 2022. Something similar with that is COVID-19 vaccine as well. So COVID-19 test, that's pretty much a noun. Some adjective that's associated with this noun is rapid. So that also happened in this time domain. So rapid COVID test. That makes sense. Another thing, I'm not sure whether people all remember the legalization of cannabis in 2018. So of course, marijuana was being talked about hugely in 2017, 2018. Cannabis Act, where's that? Cannabis Act also being talked about loud in 2018. Something very similar to that is talking about the medical purpose of the cannabis, which is here, also being mentioned a lot in 2018. Those are all associated. That's something that you see like a bump in the certain years. There's also something that in the lobbying activity has always been mentioned, like transportation or transport. That's one of the main topics over the years. Every year there's mentioning about transportation, transport. Something else, like remember the width of this band indicating the frequency of that word in a certain year. Let's look at Olympic. So the the ban for Olympic is only like increase in the year of 2009 and in the year of 2021. I believe in the year 2021, people were talking about the postpone of the Tokyo 2020 Olympics. And the year 2009, I believe that's relevant to the Vancouver Winter Olympic game. There you go. We are seeing the entire thing over the years. Every single topic in the lobbying registration text. We can also further subset this to a subset of years and also to a subset of topics. For example, we'll just mention the Aboriginal affairs. We can keep track of that relevant topic in many years as well. We've been doing this, but we have been having obstacles. I'll let my group member Cindy talking about one of the obstacles we had.
Okay, so the process of how we build all the deliverables we introduced to you was not that simple. There is still a fundamental intermediate step, which is entity resolution. Here I'm showing you two networks we built using the same data from same time range and for the same subject matters. And you can see the first one is before we did the entity resolution, and the second one is after entity resolution. Obviously, the number of nodes and edges reduced by a large amount, but specifically, if you look into this part on the leftmost side, you can see there are 4 darker green nodes here in circular shape, and they're actually representing the same company. One of them is named International Boreal Conservation Campaign, and others could be International Boreal Conservation without campaign. And what we did is actually group them into one standardized name so that you can see on the right-hand side here, the lighter green color node is called International Boreal Conservation. So this is how we make the network and even our bar chart to convey a more clear information. And here I'm showing you multiple inconsistency in our company names. Most of them could be really common when you're dealing with text data, like whether the words are capitalized or not. Different suffix can be used for same company. And also different language could be used, whether symbols are included or not. Also, different number of space, typos, and duplicates. But the most special problem about the company names is that similar names can represent different organizations like Rogers Trucking and Rogers Communications. They sound similar, but they do totally different things and they're a different company. And also there could be subsidiaries with distinct names. I guess everyone knows Rogers Communication and Fido, but maybe only a few of us know that Rogers Communication owns Fido. And also, lastly, the company names could change over time. So the first step of our entity resolution is text cleaning. Basically, we need to solve all the problems I mentioned before. We remove the French by deleting everything after slash, because we found that most of the French words are after slash followed by English name. And we also turn everything into lower cases, remove the stop words, digit, symbols, and duplicate words. We standardize the space and sort the words in each entry alphabetically because we noticed the cases like Rogers Communication and Communication Rogers. Also, we did the fuzzy matching based on Levenshtein distance. We compute the Levenshtein distance between all unique string pairs, and then we just manually go through all the groupings and set a low enough threshold for different data sets to make sure that we're not grouping actually different companies. Finally, to achieve higher accuracy, we did include some manual work in entity resolution process. We used OpenRefine, which provided us all the possible clusterings using different clustering methods. So what we did was just go through, try all those methods, go through the possible clusters, check all the names in each cluster to see whether they're actually the same company. If they are, then we just need to merge them. And thanks to all the work we did using computer, using text cleaning, fuzzy matching, now we don't need to spend that much time on manual work. So yeah, after that, we were able to pass the data to build the deliverables we showed you before, like the bar charts and networks. So finally, I will pass it to Yadong to introduce our future direction and conclusion.
So Cindy just showed us the limitations or the obstacles we had with the data set. What I'm going to introduce you is the limitations of our work, our actual work, and how we want to improve that in the future. So in the topic modeling, we had more than 350 topics. And some of the topics look very similar. For example, there's gas emission, climate change, and air quality. Those are 3 different topics, not terms in one topic. You can further group them into one larger topic cluster to reduce the number of topics. Another thing we could do is to build recommendation system based on the registration tag similarity. We'll show you the recommendation system based on the nodes, the connections among the nodes. What we can do something else is that it's actually see in the registration tags, some companies did similar things. We can further group them together, also give them a similarity score among those companies as well. Another thing is that we also looked into government funding data. Government funding are government funds given to different companies. For example, in this graph, it is the top 8 companies that receive the biggest amount of government funding in this year. What we don't know is that what did they do in their lobbying act to make sure they get that much funding. And also this could be to investigate this, it could be give them a better idea how to do their lobbying activity more effectively, efficiently. The last thing is what we're using, we'll introduce you the node-to-vec system. That's one of the basic graph neural network system. That thing is cool. It's easy to implement. It's also it's fast for computation. What it doesn't consider is the attributes of the edges. For example, it does not know how many times 2 connections are having together. It also doesn't know the temporal domain. What we build is we collect all the 15 years data and put them together and build a recommendation system. It could be the case company like Rogers talking to Eric in this 3 years, but switch target to another person for another connection. We want to build another more complex graph neural network based recommendations based on to incorporate those like temporal effect and also the frequency effect in the same network, in a communications, in a recommendation system. To conclude, over the DSSG fellowship, we turned the IGF tabular database into interactive bar charts that could be easily grabbed, could be easily taken away. We also presented the connections among the tabular databases, showing the connections between the lobbying companies to the public servants. We built a recommendation system based on the connections and the nodes. We extract the key topics of the lobbying over time and show them in the word stream. We also tackle the obstacles we have. For example, get the name standardized. Last but not least, we gain friendship. We love each other. We enjoy work with each other. We love to work with each other. Thank you all for coming, and thank you DSI for organizing this DSSG fellowship for all your support. Thank you the IGF group for your data set, for all your support. Thank you so much.